Hello everyone. Since we have already deployed our front end in the S3 bucket, now let's see how we can deploy our backend. So firstly, to deploy a backend, we need to create a virtual private cloud in the AWS. So inside the virtual private cloud, what happens is the front end will communicate to the backend via this application load balancer. So this will act as a single entry point for front end to interact with the back end, and internally this application load balancer routes traffic across different services. So based upon the paths, it will redirect to the respective service. Suppose for example, if path has order, it will route to order service, and if it has login, it routes to auth service. For products, it's route to product service, and if it's cart, it routes to cart service. And this VPC will have an internet gateway attached to it, and through this, our inline traffic will flow through. And we will have the two subnets. One is public subnet 1 and public subnet 2, and it will be hosted in two different regions. And because if you host in two regions, if one zone goes down, the still the application will be available. That's why we need to host in two different zones. And then I will be making use of this ECS service, Elastic Container Service. I have already published my image, Docker image, to my Docker Hub registry, and I have made it public so that anybody across the world can pull it and run the Docker container. So we will be making use of this AWS Fargate, which is a serverless thing managed by AWS for this containerized applications. So I will be now going to the AWS console. So I have gone through this AWS console. Now, firstly, I will go to ECS. Before going to ECS, let's go and create our virtual private cloud, which is the networking part of AWS. So it has multiple elements inside it. Firstly, let's create one virtual private cloud. So I already have this created. Okay, now let me delete this. And let's see whether I have any subnets. Okay, these are default subnets and route table. Okay, I already created a route table. Let me delete that also. Internet gateway. Okay, let this be there. And now let's go and create our virtual private cloud. Create a VPC, and let's go for VPC only option. And let's give our virtual private cloud as Vignesh VPC, and decider block in .0.0.0.16, and let's create a VPC. Now you can see that we have created a VPC, but there are no subnets attached to it, and this is a default route table, and there was no internet gateway attached to it. So we need to create all these three things. First one is the subnet, and the second one is the route table, and the third one is the internet gateway. So firstly, let's create a subnet, and this is the VPC we have created, and let's name it as public subnet 1. Availability zone, I will just keep it as Mumbai and 1A. And this cider block, it's asking for a cider block, and let's give it as 0.0.1.0 and 24. So the it can accommodate up to 256 IPs. So this is little complicated thing. There are website CADR. You can just search for the CADR. You can just toggle this 10.0.0.0 and 16 and 24 and 32 you can give. It will give you a different range. You can go and read about it more on that part. And I will just create a subnet. So the first subnet is created, public subnet, and there is no auto assign IP attached to it. I think I need to attach this as well. Let's go to this thing and enable auto assign IP address attached to it. Okay. Okay. Now we have created this thing, and I will create one more subnet. Since I told you that I will be creating two subnets to maintain availability. Now let me name this as Vignesh public subnet 2. And available zone, we have already selected this 1A, so let's go for 1B. And 10.0.2.0 slash 24, create a subnet. Here also there is no auto assigned IP. Let's go and add that thing. Even though we have named it as public subnet, it is not public subnet because we haven't attached a gateway to it, internet gateway. So once you attach the internet gateway, then only it becomes a public subnet. So now let's create a route table, and I will just name it as Vignesh public route table, and VPC is this VPC. Okay, so far so good. And we have to attach a subnet to it. So let's edit subnet association and add these two subnets to that route table so that it can route the traffics. Okay, this is good. And we have added these things. And now let's create an internet gateway. Mesh internet gateway. Attach to VPC. Select a VPC and let's create a Vignesh VPC. Let's go and attach a VPC, Vignesh VPC. This is, let this be by default. We have attached the VPC, and let's go to VPC and let's see. You can now see that this is the VPC name, and we have created a two subnet, and we have attached the public subnets, and this is the cider range, and this is the cider range for it. And somehow this internet gateway is not attached to it. Need to take a look why this is not getting attached. Okay, I think we need to attach that. Let's go inside this. Let's go to route table, edit route table. This is only local is getting attached. Where is the option to attach to the internet gateway? Now let's go to the security group. Firstly, let's create a security group. I will be coming back to that part. So attaching internet gateway. So allowing all traffic. So for now, I will be creating this security group to allow all the traffic. Even though it's not a good practice to allow all the inbound rows. See, it itself gives you a warning to not allow from all the IP address. But for the learning purpose, we are going for it. And we have created these groups. Let's go to EPC. Okay, route table we have created. We have created a subnet. Yes, here we need to attach it, add a route, and then attach our internet gateway. And we have created an internet gateway in this name. We should attach the internet gateway. Let me check that settings. Route tables. So we have attached the internet gateway. Now let's go and check the resource map. You can see that it got attached. So, so this is a networking part we need to do, and this is pretty much on the networking part. Next, what we need to do is we have to go to ECS. So it is Elastic Container Service. So it is fully managed service provided by AWS. So you have two options. You can either go for ECS on AWS Fargate or Amazon EC2. If you opt for the Amazon EC2, then you have to manage all the service configurations and all. So if you go for AWS Fargate, it is a serverless option. So there is no override you need to work on. So it's a really useful service, and you just have to pay. as you use service. So firstly, you need to create a cluster for it. Cluster is nothing but a group of tasks. So now let's name this cluster as mesh cluster, and I'm going for AWS Fargate. See if there are any defaults. Okay. Okay. Monitoring, these are optionals, and encryption is also optional, and tax is also optional. Let's go and create it. So till the cluster creation is in progress, now let me show you what I'm going to do. So I have these three services already hosted on Docker Hub. So this all three service will run on three different ports. Hot service will run on 301, and this will run on 3002, and cloud service will run on 3003. So I will be pulling these images by creating a task definition. This what this task definition does is it just pulls the image from the Docker Hub, and then I will be triggering this AWS Fargate for it to create a service for these applications inside this cluster. That is what we are going to do now, and you can see that a cluster got created, and there are no services inside it. Now let's go and see how we can create a task. So now let's create a task definition. What is task definition is? It is a single deployable unit. It is the smallest deployable unit available in ECS. So firstly, I'm going to create a auth service, right? So I will just name it as auth service, and I'm going for launch type as AWS Fargate. It is a serverless compute for containers, and I will just go for one virtual CPU and 2 GB of memory, and this uh, let it be by default, and the container, and I will just name this container as service, and this image it is going to pull from Docker Hub. If you are not familiar how this Docker image gets built and pushed to the Docker Hub, you can watch my previous videos and learn about it. And this is the container port, and the container is going to run on 3001. So while building the Docker image from the Docker file, we have this expose thing. So I have already exposed 3001. So that's why I am giving this as 3001. Now let me open the folder and show you my microservices, backend microservices. And if I head back to auth service Docker file, you can see that I have exposed this 3001. Hence I'm giving here as 3001, and the port name auth service, and the rest of the thing let it be by default, and I don't need a logging mechanism right now, but this is really useful if you are going to monitor your production applications and other things. Okay, so we have created this task definition for auth service, and now let's head back and create one more service for product. So product service, and I will just name this as AWS Fargate. Let's go for the same memory we have used for the auth service, and the container name is product service, and the images Vignesh Tech and product service, and this is going to run on 3002, and the port name, this is optional, but anyhow let's name it as product service, and I will just uncheck this as we did for the auth service. And we have created task definition for auth service and product service. I will create only one more service, and that is going to be cart service. So cart service, and the launch type is going to be AWS Fargate cart service, and the image it is going to pull from the Docker Hub registry as this one, and it is going to run on 3003. Let's name this also as cart service, and check this CloudWatch logs. Okay, now we have created a task definition, but we need to create a service. Then only our application will become live, right? Before creating a service, I have already mentioned that the front end is not going to talk directly to my application, but it is going to talk to the application load balancer, and this load balancer routes the traffic from front end to the respective services. So we need to create an application load balancer first. So let me duplicate this. Let me go to application load balancer. So application load balancer resides inside this EC2. So firstly, let's go to load balancers, and we need to create a load balancer. And we have various load balancers: application load balancer and network load balancer and gateway load balancer. You can read more about it. So I'm going for application load balancer, and we can name this load balancer as Vignesh load balancer, and let this be internet facing because it is the one who is going to talk to the UI, right? So let's keep it as internet facing. And the network mapping, we are going to select our VPC, and the availability zones, we have already created these two public subnets on two different zones. And the security group, you remember we have created one security group, so but that security group is not coming here. Okay, now let's go to security group. Need to go to security groups. We already created a security group, but it is not getting attached to the VPC. Now let's go and check the VPC, associate VPC, and yes, this was not associated. That's why it was not showing up there. Think I need to refresh it, and yeah, you can see that the security group is coming under this VPC, and this is the most important part. So it is going to face the internet, right? So it is going to come via HTTP protocol or the HTTPS protocol. If it's HTTP, then the port number, default port number is 80. If it is HTTPS, then you have to manage this certificates and all. So currently I'm opting for the HTTP service, and it's going to listen on the port number 80. If it's HTTPS, then it will listen to the port number 443. Now, before creating this thing, we need to create a thing where it is going to forward our traffic to. So it is going to come via 80, but we need to route to the different services, right? It may be a auth service and product service or a card service, and each service is running on different port. So to route this traffic, we need to create one more thing known as target group. So now let me duplicate this and go to the same EC2, and if you just scroll down, you can see the next to the load balancer there is a target group. We need to create a target group for it, and you need to select this IP addresses, and let me name this target group as hot service, and the traffic will come from port number 80, right? And the VPC is going to be our VPC we have created, that is Vignesh VPC. And now let me go back to this thing. Let me remove this, and our service is running on port number 001, right? So I will just give it a 001 3001, and I will just create a target group. So we have created one target group for auth service. Similarly, we have to create for two more service, that is product and card service. So target group, and it is going to be a product service, and this is going to be 80, and the VPC has to be same VPC, and let's remove this because this AWS VPC it will take care of all these things. ECS it will take care of routing these things. So this will be running on 3002, and you can create a target group. And we have created a two target group, and we need to create one more target group. And I will just create a card service, and it is going to listen to same 80, and the VPC is going to be my VPC. And let me remove this, and this is 3003. Okay, we have created a three target groups, but we need to attach that to this thing, right? So where are we? So we were creating a load balancer. Okay, and I will just keep this as default target group as this auth service for now, but I will be making changes, defining the rules during the later part, and the rest of the things are going to be same. Okay, you can see that I have created this load balancer, and this is the internet facing, and we have already defined the rules for it, and I will be adding a rule to it, more rule to it, this thing. I will just add this rule, and I previously told you that I'm going to add a path based routing mechanism. So if it's a login, then it will route to auth service. So if it is login, then it need to route to auth service, right? So forward to target group. That's why we have created a target group. So it is going to go to the auth service. If it ends by login, then it will go to auth service, and it will ask for a priority, and Let's give it as priority one. Let's create. Yeah, we have created this thing, and let's add more rules because in my image I have also ordered this products and cards, right? So I will be adding a condition. So if it starts with products as well as if it's go products slash and some other routes, then it have to go to product service. So route to product service. Let me assign a priority as 2 here. Create, and let me create one more rule. We have created auth products, and one more thing is cart. So cart is also this one, path, same path, and cart, and target group is cart service, and 3. Okay, we have created the rules for it. Actually, my application don't have this course header, so we will be facing a issue. So I will show you that issue later. So I will be attaching attributes and add the header, certain security headers here once we deploy our application. Now we have created an application load balancer, right? So make sure you delete this application load balancer if you are doing it for a learning purpose, because this ECS Fargate itself cost you. So make sure you turn off after you learn something. So you see that there are no services. We need to create a service. So we have already created a task definition. First, let's go to this auth service and the service name. Okay, and let's go for the launch type, and it's going to be Fargate. And how many replica sets you need to deploy. So if you deploy 3 replica sets, then minimum always 3 instances will be made. So that is for being a cost effective. I'm just going to create a launch only one number of tasks for it, and the networking, and I will be making use of the VPC we have created, and we have already created a 2 subnets. So it requires a minimum 2 subnets to be created, and we have already created a security group. So I don't know why that is not coming up. Okay, the security group is not coming up. We go back to security groups. Let's see whether this VPC ID is same as this one. Now this VPC ID is different and this is different. And let me refresh this and then come back. Auth service, task definition, auth service, and launch type. It's Fargate and networking, Ignish security group, and this is same as this one. And the security group. Mhm. To submit. Under DA and this is under DA. Then okay. Now I will come back to that part later. And we are going to make use of the existing load balancer, and this is going to be this load balancer, and I have already created a listener, right? So we have attached a port and all there. Use the existing target group, and if it's going to be auth service, it is going to be auth service. So only this part is the problematic. Security group. This VPC ID is different, right? So I think that is why the problem is coming. And security groups, and this is 27. I think we need to change this associate security group, but this VPC ID is not changing. So this is the security group we have created, but we have attached a wrong security group here. So now let me delete this thing. VPC associated. A4 is this one. Yeah. For now, I will just edit this inbound traffic rule and allow the all security group. Okay, that is by default enabled. Add a rule and delete this rule and allow all traffic to flow in. All traffic. The associate. Let's see if some problem comes up, then we need to change the security group. For now, I will just create one service, and the service is getting created. Once it is created, it will get displayed here, and you can go to the service, and then a public IP will get enabled here. Before that, let me create a product service because I have a GET request at my product service, so we will be able to access it on the internet itself. So let me create a product service. On type is going to be Fargate. The rest of the things it will be by default. And let me come to this our private group, and this is same. And here also it is going to be problematic later. And use the load balancer and the application load balancer, and use the existing load balancer, and it is going to be Vignesh load balancer, and the target group is going to be product service because we are creating a product service, and use the existing listener, and okay, and this is going to be product service. It will just expose this public IP, right? You can copy that public IP, and then it is going to run on localhost 3002 since it's a product service, and I have this endpoint, this products, so it should be accessible because I have enabled it in the public subnet, right? So you can see that it is accessible. This is good, and I will just create one more service for cot, and this is going to be cot service, and the launch type same Fargate. Networking is going to be mesh, and just existing security group, okay, and the load balancer, use the load balancer, application load balancer, use the existing load balancer, and it is going to be Ignish, and existing listener we have already created in the application load balancer, and it has certain rules, and now we are going to redirect this uh, to cart service, and it will run on local host 3003, not local host. It is going to run on 3003, and the cart service will also get created. So once that is created, it is accessible via localhost 3003, and I have a route for accessing the cards. So I will just enter this and just delete all this thing. and it is going to be 3003, and then we have to enter a public IP attached to it. Let's go to cart. Let's go to here and check for public IP attach HTTP. You can see that the cart service is also working and the product service is also working. So auth service will also work. But the thing is, why we have created a application load balancer is all the services UAE will talk to this application load balancer, and this will route the traffic to each other, right? So we need to go to application load balancer and get a DNS name there. So application, okay, we are already inside the CCS. Let's go to application load balancer and check for its name. What is the name of this application load balancer is this one. So I will be doing this, and if I access the products, then it have to route to products. But this is not somehow getting reached. So this is the problem we are facing now. I think this is happening because of the security groups, or we may term it to some inbound traffic. Now let's check. Let's go to application load balancer. We are already inside. Okay, load balancer. Whether this is HTTP. Oh, this is HTTP. Yes. Okay. Yeah. Now it's working. Okay, our application is actually working now fine, but we need to do one more thing. That is, I have already built my front end application in my previous video, and I will be going to that code base, front end code base, and then change the base URL of the thing. Okay, and change the URL here. Okay, okay, I have to run it as administrator because of my system settings. My bad. And just to make use of this Vignesh application load balancer and this thing, now I will just create a build, npm run build, and it will give me a build file. Okay, some problem with my system, pardon me. Let's go to front end svelte. Mm, this is right. Okay, I will do one thing. Command prompt run as administrator cd. Now let me head back to my application into Svelte e-commerce. Now npm run build. It will build my application, and okay, my application got built. Now I will go to the S3 because I have in my previous video I have hosted my front end on the S3 bucket, right? But I haven't updated the URL since we haven't created a application load balancer, and I will be deleting all this thing from my bucket. Yes, delete it permanently. Good, it got deleted. Now I will upload, add files. Firstly, I will add the files, users, Ignish, Svelte, and build. So we are going to add the files. Okay, and then add folder, and folder is going to be this thing. Upload. Even though these applications are running on different port, but this application load balancer will drive it the traffic to each port. That is the main benefit of this application load balancer. Okay, bucket got updated. Now let's go to this bucket and get the name of the bucket. Okay, our application. Now let's user 123 and the password is password. Now I will try signing it. So I was telling that we will face one issue, right? This is course issue because in my application I haven't added a course policy, and I have this various microservices, three microservices running, and I need to add this header to each and every microservices. But I don't want to deploy this thing in my each and every microservices. There is a way around. I will be doing that now. So it clearly says that my S3 bucket can't access resources from my application load balancer. So we need to configure settings on the load balancer and add this. I was previously mentioning that I will be adding attributes, right? So what does it say? Firstly, what does this say? It tells to add this access control allow origin header on the head request, right? So I will be doing that now. So edit this at the request allow access control origin, and I will allow it from all the origin. But this is not a good practice. But for now I am adding. Usually what happens is you have to allow origin from this domain alone. So that is a course policy that is for security reasons. We will be adding which domain can access our domain. So this header is there, right? This allow access control header. Uh, we will be defining certain things there. So before doing that, I will just add all this header permissions, and this header we need to add these two conditions, that is content type and authorization. Okay, now I will save this. Now once saved, now let's hit the thing. It might be because of the cache also. So let's go to incognito You can see that it works. So if you see that I will be accessing from the application load balancer. So and once this is done, it is code routing to products page. And actually this products page is running on 3002, and this login page is running on 3001, and this product is running on 3002, but we are using the same application load balancer URL. So actually it is working fine, and I will just route to products and slash. We have added a rule, remember that product slash and then star we have added. So uh, that is a dynamic routing. And if we go to carts, it is trying to fetch this cart from cart service. So I will just add some cart here and then go to cart. So it is fetching from carts. You can see that it is routing to cart service. So this is how our applications works, and hope you learned something new in this video. So thank you for watching, and make sure you delete the resources once you learn, because it's going to cost you if you are not going to delete it.